Hello everyone. Today we are going to do a demo using Prebuilt ML models, and we'll leverage Cloud Vision API and AutoML capabilities from Google Cloud Platform. Idea here is to create a data set of images, inspect those images, uh, create a training data set from those images, and train our model based on those images, evaluate our model, and then generate some predictions. So that's the overall goal of our demo here. To start with, we'll have to activate Cloud AutoML APIs. So let me go here and search Cloud AutoML API. So as you can see here, we have this Cloud AutoML API installed, and it is enabled. Once your Cloud AutoML API is enabled, we'll have to set up AutoML Vision. Now, to set up this AutoML Vision, we'll have to leverage a few capabilities. We'll have to export, we'll have to do some configuration here. So if you can bear with me for a few minutes, let me set up those configurations. By doing so, if you see here, I had click on this Cloud Shell. Essentially, it gives me a shell interface to Cloud SDK, and it's all happening from your Google admin portal itself, Google Cloud admin portal itself. Give it a few seconds while it starts. So now if you see here, I'll have to enter all the details. Give me 1 second while I enter all these details. So if you see here, this is my project ID. I would also need to address access username. So since we are creating a dummy username here, we'll have quick labs. So here we are defining our initial setup. Now we'll need to create a storage bucket where we'll be having all of our images to do our testing. So if you go here, this is where I'm creating all my a folder where I can go and grab all my images. Now we'll have to open a cloud. Now we are done here for time being. We'll have to create a new interface, and we'll have to navigate to AutoML UI. So if you look here, AutoML. So if you see, there are different kind of information here. You have your metrics, you have your quotas. There are different interfaces here. Give me 1 second. My system is kind of slow here. we need to go and look at the data set. So if you see here, there is no data here to be shown. Now, what we'll have to do is we'll have to upload our data uh, from the storage. So if you click here, navigation, you can go to storage. So you see here we have this bucket created, and this bucket we created using our project ID and everything. So now if you that's your bucket name. So now if you do export bucket equal to your bucket name. Now your bucket name. So essentially you're just setting the variables here. So we have these images available in the public domain. Now we are pulling it to our bucket. So right now the images are getting pulled to our bucket. There is an issue here. So let me echo bucket. So now you have pulled everything to your bucket where this is your bucket. So if you see here, this name here, Quick Labs dash GCP, that's the bucket that you have created. Now this bucket has all the images that you have sourced in from public location. So now if you go ahead and if you try to refresh here, and then if you try to click this bucket, so you have your bucket details, you have all this information here. So if you see here, you refresh your bucket, you have all this information here. Subject to AC, you have cumulus, circus, cumulonimbus. So this, you have all these folders here created. Now, essentially what we're trying to do is we are trying to create a data set. So we have the folder structure, we have these images. Now we are trying to create your data set. And this is how we create our data set here. You have to go to, you use your GSUtil capability, and then you copy your data.csv file into your current folder. So now you have copied your information. Now you need to update your CSV files. You need to find where your CSV files are. Essentially, you're just trying to do some regular expression here. Now we are ready to upload this file into our source bucket that we have created. So if you go here, you write this GSUtil, it will copy it to our bucket. So we have data in our bucket right now. You can go ahead and you can do a quick refresh and you'll see your data.csv. So if you see here, you have this data.csv file available. Now we'll go back to our AutoML vision AutoML location. So if you come here, you see here, you click on this data set. You click on add new data set. Dataset name would be cloud. We're just using it for our test purposes. Single label classification, check single label. We go ahead and so we keep here single label classification because the data that we are using right now, we are just going to do single label classification for it. We go ahead, create data set. So now we have created our data set. Now we have to pull this information. So we have to select our data from the file that we have, right? So we have to go here, we'll have to select a CSV file. We'll have to go here. If we go and click browse here, so we will have our data CSV here. Click on select, it is selected. Make sure you have your proper bucket name and you are pulling it accordingly. Click continue. So right now you're importing images. This will take us approximately 8 to 12 minutes because we are trying to load the images. And as you see here, you have this images, import images running on right now. Now, if you click here, you see here, there are import, there are images, there are train, there are evaluate and test and use. So each of this option is a different, images will give you list of all the images that you have. Training is where you can go and you can write your small script to train this data, and then you have your evaluation, and then you do some kind of testing on that. So we can go on images here. So yeah, because it is still pulling the information, you won't have any data available here. But after once this import is successful, you will have your data in this image folder. Looks like we have a job that is running, and I think it's not able to pull this information. Looks like there's some kind of issue going on here. So let's go back and see what's the issue there. So if you see here, it's still importing all these images here. So with running import, it would take some time. So let's give it a few more minutes. because we are loading quite a few images, this would take approximately some time. So let's give it a few more minutes. It looks like this is still running. It's still running, so let's give it some time. So now if you see here, your process is successful. We have uploaded approximately 60 images, as you can see here. So let me go inside the folder and see. So if you see here, I have all these images uploaded. These are different kind of clouds. And what we are going to do is we are going to classify whether given a particular image, how accurately we can classify type of cloud among whether it is cumulus, whether it is cumulonimbus, or it is circus. So that's the overall goal that we are trying to accomplish here. So if you see here, we have like, if you look at the filter labels, you have 20 images for each type of cloud: circus 20, cumulonimbus 20, and cumulus 20. The important point to note here is that right now our training set is only 60 images. But let's say if you are building a production level model, you would at least need 100 data points. We can do, for a small demo like this, we can do with 20 odd images, but if you're trying to build a large scale demo, you would at least need to have 100 data points. The idea here also is to think about what if, and what we're trying to do here is we're trying to give system an image and see what kind of prediction they come up with. But we can also give it trained data. So we can manually configure like what kind of data element we have or what kind of image in this case we have, and then we can do some kind of manual labeling on the data. So that way we are giving additional information to the system itself for creating an accurate prediction. Now, if you want to look at the stats of this data, you can click on the label stats image here. Now, what we are seeing here, it gives you a clear view in terms of what was the initial data set, what kind of data element we have taken into our consideration, what portion of that element will go through training, validation, and test respectively. So essentially, you still need to, like, if you have only 10 images, you need to have 8:1:1 ratio kind of split up to assign to your train, to your validation, and to your test sets. Now, if you click on train here, train tab here, we are not using any, if you see here, we are not using any unlabeled images. Our data set that we are uploading, AutoML interface, Cloud Vision interface, would automatically split that data into training data, your validation data, and your test data. Now, as I said previously, the split here, it has to be 8:1:1. You want to have training data as big as possible so that your models are able to learn from this data. And initially, we will, here for this demo, we are starting with labeled data. So your system will look at the data, understand what a data type is based on the label that we have assigned to it. And then in the predict phase, it would look at a new image, and based on its learning that it has built, looking at your labeled training set data, it would be able to clearly predict whether a new image, in this case, is cumulus type, circus type, or cumulonimbus type of cloud. So now you can go ahead and you can click on start training model. So you can change name here if you want. You're just doing it in cloud, so you go with cloud hosted. Just say continue, and this will start loading, training your data. But before that, you'll have to select a specific kind of, you have to define your model that we did initially, right? A few minutes back, we defined our model, what we are trying to do. We had our training model data set, we had our validation, and our test data set. Another important thing is we also need to put how much budget we want to assign to a particular node for doing this kind of training. We can go with 8, we can go with 8 node hours, we can go with 16 node hours. So there are different kind of offerings that, depending upon how much processing power you need, you can leverage that. Now you can obviously deploy it to one node after training. You want to make sure that REST APIs are available once your training is done, so that you have defined your development and deployment prices. Now, once you start training, it would take approximately somewhere around hour and a half to complete. So and this training time, so if you can see from this complete process, training time is the most important or most time consuming activity that that one has to account for. Again, when you're trying to train the data, you have to have cloud economics in mind. You have to understand how complex your training data set is, how large your training data set is, how complex your model is, what kind of prediction you're trying to leverage from the model. Are you trying to do some kind of logistic regression? Are you trying to do some kind of classification or some kind of clustering problem? Depending upon all these parameters, you have to define what kind of node power you would need for training your data set. So there are multiple different options and there's no right answer, right? Depending upon your use case, you'll have to go ahead and select a specific data element and your node configuration.